Welcome to the Material Testing Laboratory. I am Prabha Mohandas, PhD scholar in BTCM Division, Civil Engineering Department at IIT Madras. Today, I am going to explain about how to do tension test for pre-stressing strands. Typically, pre-stressing strands are widely used in bridge structures, railway sleepers and high-rise buildings, and these strands are high capacity strands of about 100 to 200 kilonewton depending on different size of the bars. So, it is very important to characterize those strands to meet the acceptance criteria to be used in the structures. So, what are those acceptance criteria? So, in tension test we will be getting the different parameters like yield strength of the materials, elastic modulus of the strand and ultimate load of the strand and ductility of the strand. Typically, three types of strands are being used in pre-tension or pre-stressed concrete systems. Those are 3-wire strands which has 6 mm diameter, and next one are 7-wire strands with 12.7 mm diameter, which is typically used in pre-tension concrete systems, and the next one are 15.2 mm diameter strands. Again, this is also 7-wire strands which is typically used in post-tension concrete structures. So, today I am going to do testing on this 12.7 mm diameter strand. So, to meet those specific criteria for the acceptance thing, code has specified minimum requirements for each parameters. For example, the 12.7 mm strand should have the nominal diameter of 12.7 plus or minus. So, we have standard specifications which gives the minimum criteria for the acceptance purpose. So, in India we have IS 14262, that is a specification used for pre-stressing strands, and we have ASTM A1061, again that is also being used for pre-stressing strands 7-wire. So, now we can start doing the testing for 7-wire strands. Before starting the testing, we need to do specimen preparation and certain measurements for the calculation purpose later. So, we need to have vernier apparatus to measure the nominal diameter of this strand, and we have dial gauge to measure the elongation of the strand during the testing, and we have the scale to measure the length of the strand before we place the strands in the testing machine. So, basically strand is made of 7 wires, 6 outer helical wires and 1 center king wire. So, to get the correct area of the strand, you need to measure the individual outer diameter of the strand and then king wire, and sum of that to get the actual area of the strand. So, you have to measure the nominal diameter of the strand using vernier caliper, then we can measure the pitch length of the strand. So, we need to measure the gauge length for placing this dial gauge on the strand to measure the elongation during the testing. So, once the gauge length is fixed, we can prepare the gripping portion of the strand. So, we need to so for any tension test, gripping is very important because we need to avoid stress concentration near the wedges. So, basically when we apply lateral pressure while gripping, that will induce stress concentration and that may affect the result. So, once we get the dimensions of the strand, we will next prepare the end region of the strand for gripping the strand in the machine. So, we need to be careful while gripping because we need to avoid stress concentration which will affect the results. ASTM specification gives we need to use special cushioning device to avoid stress concentration near the ends. So, for that purpose we have prepared this hardened aluminum plate which can be placed at the end of the strands for gripping purpose. So, you can see the grooves made on the plate on which strands will be placed, and during testing we may face some slipping. So, to avoid that, ASTM specification has suggested to use aluminum oxide oil slurry made using glycerin, and we have placed clamp at both ends make sure that the strand is not slipping or rotating during the testing. Now we have prepared the specimen for the tension test. Once the specimen is ready, we have to mount the specimen on the machine for the tension testing. So, before getting into the testing, I will just brief about the tension machine that we are going to use. We have this universal testing machine from MTS. The machine capacity is 1000 kilonewton, which is fully servo hydraulic controlled, and this is the hydraulic control system which will be used to apply the lateral pressure for gripping the strands, and this controls we have to move this upper portions to place these strands. So, now we have prepared the specimen and specimens are set and fixed on the tension machine, and we have applied initial preload to make the strand straight. Once that is done, we have placed the dial gauge at the center of the strand and measured the gauge length of the dial gauge to get the strain during the testing. Now we have placed the strand on the machine for the testing. Once the strand is fixed, preload is applied to keep the strand straight. Typically 10% of its braking strength will be applied as a preload as per the standard specifications. Once the dial gauge is fixed, you need to measure the gauge length, that is the distance between the two knife edges of the dial gauge. Then you need to measure the gap length, that is the distance between the upper and lower grip, to get the total deformation or total elongation of the strand at the end of the testing. So, during the test, you need to monitor the dial gauge reading to get the elongation at different intervals of loading. Typically, we will be taking the dial gauge reading at every 10 kilonewton interval till it reaches its yield strength. Once it has reached its yield strength, we need to remove this dial gauge from the strand to avoid the damage when the strand is rupturing or breaking at the later stage. Once the dial gauge is removed, we will continue the test till the strand breaks or till the strand reaches its ultimate strength. Once the dial gauge is fixed, to capture the post-peak behavior, we are using a displacement control method. Basically, we are applying 2 mm per minute loading rate. So, now we will start the testing. So, now we have the computer program to run the test and capture the load and displacement data. We use 2 mm per minute displacement rate to apply the load. So, typically displacement control tests are preferred to capture the post-yield behavior of the material. Then once it has reached its yield strength, there will be a detection indication to remove the dial gauge, and the dial gauge will be removed once it reaches its yield strength. Then we will continue the test till the specimen fails. Then the load and displacement will be recorded. So, here we have the computer program to run the test. So, which says initially displacement rate of 2 mm per minute is used to apply the load. Displacement control rate is preferred because we need to capture the post peak behavior also. Then the load will be increased gradually to reach its yield strength. Once it has reached its yield strength, there will be an indication to remove the dial gauge from the strand, and dial gauge will be removed. Then the test will be continued to reach its ultimate strength or the specimen fails. Then the load and displacement will be recorded, get the stress strain behavior of the pre-stressing strands. So, while test is running, here you can see the load displacement behavior of the strand, and now you can see the load is linearly increasing and the force and the displacements are shown at the bottom of the screen. Meanwhile, reading will be taken, dial gauge reading will be taken at every 10 kilonewton interval. So, now this indicates that specimen has reached its close to its yield strength, and now we can remove the dial gauge from the strand. So, now we are done with the testing, and our strand specimen has failed by breaking of single wire first, followed by second wire, third wire, and almost all the outer wires has broken. The first wire has broken at the center, then the rest 5 wires has broken at the near the upper gripping point of the strand, and you can see nice flower shaped failure of the strand. If it is properly gripped. From the test results, from the software we can get the load displacement data. Using the data we can obtain the stress strain profile of the pre-stressing strands. From the stress strain curve we can get the yield strength from the initial slope of the stress strain plot, then the yield strength of the strand, then the ultimate strength where the first wire has failed. Then finally, the ductility or the total elongation of the strand. This plot shows the axial force and displacement behavior for the pre-stressing strand. Based on this axial force, you can get the you can calculate the stress applied dividing the axial force by the area of the strand, and strain can be calculated by obtaining the axial load and displacement from the software, and this plot shows the axial force and displacement behavior of the pre-stressing strand, and from this data we can obtain the stress strain behavior of the pre-stressing strand, and this initial portion can be used to obtain the elastic modulus of the strand, and this indicates where the yield strength of the strand, and this indicates the ultimate strength of the strand where the first wire has broken and the load has dropped, and with the subsequent breakage of the outer wires, load is further dropped, and finally this will indicate your total elongation of the strand, which can be used to obtain the ductility of the material. In this section we have learned how to do tension test for the pre-stressing strand, how do you need to prepare the strand specimens, and the test procedure for tension test, and procedure for obtaining the stress strain behavior of the pre-stressing strand. Thank you.